In order to finalize the process and make it feasible, we have to add some machines, which are compressors and pumps, to increase the pressure to the pressure of the columns and to transport the water and the gas through the plant. Also, with these machines, then we will be able to calculate the utility consumption. So we see here a first warning from the column. This warning in the column is there because the tower pressure is higher than the feed pressure, which means we have to increase the pressure. We have several points where we can include compressors. So here we have the gas way, the raw biogas coming from the digesters. Then here we have the recycle coming from the flash unit op. So here we also would have to increase the pressure. And we have to transport the stripping air through the stripper column. So commonly the compressor is behind the column to move the gas, the air through this column. And here we need a pump. So I will start adding these units, beginning here from the biogas. So I will insert the unit op and I take the compressor. Now, because of the compression, the gas will heat up. So it's a good idea to cool down the gas after the compression in order to save some electricity and to avoid too high temperatures. Also, commonly the biogas from the digesters comes saturated with water. And this is why commonly there's a small compressor in the beginning and a condenser of water, and the water is sent back to the fermenter. We will simplify the process here a bit and ignore this water, so we will directly work with dry biogas at a temperature of 30 degrees Celsius. So here's the first compressor. And then here we will add a heat exchanger. I want to see this message again. So here. And after the recycle from the flash, we have to include another compressor. So I will put it here. Arranging with the streams. We can, of course, cool down the gas behind the compressor here, but this would require another heat exchanger, and commonly the gas heat capacity is so much lower compared to the water coming into the column, so it's often not necessary to put an additional heat exchanger here in front of the column. So let's calculate these parts step by step. We are coming from the digester with the raw biogas, and now we have to decide to which pressure compress this gas. Of course, it makes sense because here we are mixing gas coming from the flash, so it's a good idea to use the same pressure in this. So let's see, in the flash we specified a pressure of 4 bar. So in this compressor we specify that we want to compress the gas to 4 bar. Adiabatic compression leads to a temperature of 180 degrees. Here we are using the default value for an efficiency, which is 75% of isentropic efficiency. Now, assuming that we have common cooling water with a temperature of around 20 degrees, means we can cool down here our gas to around 30 degrees Celsius. At this point, we mix our flash, gas coming from the flash. Now stream 12 should have a pressure of 4 bar. This is the mixed temperature, 24 degrees, because the gas from the flash is a bit colder. And in the next compressor, we go to the final column pressure, which, let me check, we selected 10 bar pressure in the column. Of course, commonly the pressure drop inside the column should come here on top of this, but at the moment we ignore the pressure drops. So let's go here to 10 bar. And now we have our gas stream compressed. the temperature of 117 degrees Celsius entering the scrubber column. And the next step, we will add the pump for the water transport. So here we have a pump. Select another symbol, which is more common in Europe to use this pump. Turn it around. And let's reconnect these streams. See, I used another method, not using the insert unit op. I can also drag and drop it to the screen and reconnect the streams. And in this pump, we have to compress it to the column pressure, which is again 10 bar, which we have here. Okay, so now if we run this yellow warning should go away, because now our streams, stream 1 and stream 17, have the same pressure as the column pressure. So now we have to transport this air through the stripper column. So this air comes at ambient conditions, 1 bar 20 degrees Celsius. What we can do now here at this point on the top, we must have a lower pressure than 1 bar. If not, the air will not enter the column. Currently, we don't know what's the pressure drop in our column, so I specify 950 millibar as an absolute pressure in this column. And now we can compress our off gas by adding another compressor here. Reconnect the stream. And in this compressor, we specify a slide over pressure with there's some units behind. Commonly, there's an regenerative thermal oxidation to remove the rests of methane. So we need a slide over pressure here. I'll specify 1.05, so 50 millibar over pressure from this compressor. And now we have all the pressure machines inside, and we can run our flow sheet. And we see recycle converge after 10 iterations. And now we can see all the electricity consumption coming from our compressors and from the pump. You can see our slightly changes in temperature and everything might have affected our methane purity, but we see our process still is in a good state. So we have here more than 98% of methane.